Welcome students. We are back with another lesson. In this lesson, we will derive our final kinematic equation, the third kinematic equation, v square minus u square equals to 2as. Fine. So up till now, we have derived the velocity time relation where I have showed my final velocity v equals to the sum of the initial velocity u and the product of acceleration and time. Fine. So this is the first expression which I have derived. Then using the average velocity formula. Okay, the average velocity is total displacement upon total time taken. Also, your average velocity can be written as the initial velocity plus final velocity divided by 2. Using this two expression, I have derived my second kinematic equation, which is s equals to ut plus half at square, where s is the displacement, u this product ut, where u is the initial velocity, t is the time interval, a is the acceleration, and t is the time interval. So the displacement can be written as the sum of the product of the initial velocity and time and half of the product of acceleration times time square. Fine. Using the expression for the average velocity. Fine. So now in today's class, we will derive our third kinematic equation. So far we know that the velocity time relation where the final velocity v can be written as the sum of the initial velocity u plus the product of acceleration times time. Okay, now if I send this u to the left hand side, then I can write this expression as v minus u equals to at, or I'll say the difference between the final velocity and initial velocity is equal to the product of acceleration multiplied with time. Fine. So this is the difference in the velocity. Let's give this equation some number. Let us say equation 1. Also we know that our average velocity is the displacement, the total displacement upon the total time taken. Fine. From my last class, I have showed that your average velocity can be written as the sum of initial velocity plus final velocity upon 2. So if I write this average velocity in terms of initial and final velocity, then I'll write the sum of final velocity plus initial velocity upon 2 equals to the displacement, the total displacement upon the total time taken. Fine. From here I can send this 2 to the other side, cross multiply. I can write the sum of the final velocity and initial velocity as the product 2 times s divided by the total time taken. Fine. So the first expression gives me the difference in the velocities and the second expression gives me the sum of the velocities. Now let's combine our equation 1 and your equation 2. I'll do it in the next slide. So if we multiply our equation 1, this one, and our equation 2, okay, we will get, first look at the left hand side part. Okay, here you have v minus u and here on the left hand side you have v plus u. So let's multiply the left hand side part first. So I can write down v minus u multiplied with v plus u. Fine. Now look at the right hand side part. On the right hand side you have at, on this right hand side you have 2s upon t. So multiply the right hand side part. So I can write down at times twice of s upon t. Fine. Now let's look at the left hand side part. Using my algebraic expression, a minus b multiplied with a plus b will give us a square minus b square. Similarly, if I apply the same algebraic expression here, so I have v minus u multiplied by v plus u, I will get v square minus u square. Fine. Now look at the right hand side part here. Here I can cancel this t. Fine. If I cancel this t, what I'm left with? A multiplied by 2s or I can also write as twice of the acceleration times displacement. Therefore, I got my final expression, the square of the final velocity minus the square of the initial velocity equals to twice the product of the acceleration times displacement. So this expression is my velocity displacement relation for a constant acceleration. That means I can find out the displacement S if I know the final velocity, the initial velocity and the constant acceleration, or I can find the other way around also. If I want to know the final velocity, then if the question has given initial velocity, the constant acceleration A and the displacement S, then you can find out your final velocity, right? Similarly, in the same manner, you can find your initial velocity. So this is the final third kinematic equation, which is also known as your velocity distance relation, right? So that's it for today's class. Thank you. And if you have any confusion, please feel free to ask. I will re-explain it to you again. So again, thank you.